I'm making the most shy robot in the world. He'll act awkward, avoid conversations, hide in his hoodie when he feels nervous. The only problem is I've never built robots before, but I'm already halfway there. So today I'm taking you through my entire journey from zero to a complete robotic body with all components installed and working. If you're a beginner, this video is packed with beginner-friendly knowledge. And if you're an experienced robotics or electrical engineer, please stay. I really need your help in the comments. Let's get to it. First, we need a brain and a source of power. I'm using this tiny thing called Raspberry Pi, and it's basically a mini computer. You can literally plug in a monitor, a keyboard, and a mouse and use it as a regular computer to browse web, watch videos, whatever. Now, unlike your computer, Raspberry Pi has this exposed metal pins on top. Almost anything you want to connect to the Pi will have to be connected through these pins. But it's important to know what pin does what because they aren't all the same. Some provide power, some are ground pins, and whenever you connect power, you need to connect ground to complete the circuit, and some are specialized in sending specific type of signal. The first thing I connected was a monitor, this LED screen that will display his eyes and facial expressions. The only problem was it required soldering and I tried very hard to avoid it. For example, I bought these breadboards. They allow you to connect components without soldering. Sounds perfect. And they are great for prototyping. But there is no way I can fit a prototype with breadboards into any reasonably sized desktop robot. Any somewhat complex robot just isn't doable without soldering. So I decided to face my fear and go for it. I was so nervous about this. I took every precaution possible with protective glasses, a plastic mat on my carpet floor, heat-resistant mat on the table. I watched like 5 YouTube tutorials, God bless YouTube, and then I went for it. What I was soldering was this breakaway strip male headers onto the screen. Basically metal pins that the female side of the wire connects to. Turns out soldering isn't as scary as I thought, but it's also extremely hard to do well as a beginner. I actually soldered both connection options, top pins and side pins. Good thing I did because the top connection straight up didn't work, so I ended up using the side pins. The screen takes 4 pins, power and ground, which are standard for every component, and SDA and SCL. These 2 pins handle I2C communication. Basically, they are how the Pi sends data to tell the screen what to display. Initially, I connected all of them directly to the Pi. I wrote a quick Python script to test it with a simple smiley face animation, and when it worked, oh my god! My background is in software engineering and AI, so I know the feeling when something you envisioned actually works. But doing it with hardware is like joy times 2. There's just something about making physical things light up that feels magical. But then I discovered a problem. My servo board that we will connect later also needed SDA and SCL, and Pi only has 1 pin for each of this. So I had to get this I2C multiplexer board. It basically splits those pins so multiple devices can share them. Next up was sound. The robot needs to be able to listen and speak, so I got this tiny speakers and an amplifier board to power them. The speakers on their own are just too quiet when connected directly to the Pi. The audio signal isn't strong enough, so we need an amplifier to boost the signal and make them actually usable. At first I tried connecting the amplifier directly to the Pi pins, but it could only play simple sounds such as this beeping one. Nothing more complex like voice or music. That's because the GPIO pins can only output basic PWM signals, which work for bips, but not for actual audio playback. So I had to get a USB to audio jack adapter and connect that to my amplifier. This way the Pi handles the audio processing through USB and outputs proper analog audio. I soldered the connections on the amplifier board. Still not perfect, but definitely more confident than my first attempt. For the microphone, I went with a simple USB mic. No soldering needed. We'll just plug it in directly into the Pi through USB. I ran a quick test to make sure the Pi can play sound through the speakers and recognize sound from the mic. Everything worked, which means our robot will be able to listen and speak. The only issue is the speakers make these scratchy noises.
Front, right.
It could be because of the cheap amplifier, bad connection, I don't know. I'll go with it for my first build, but for the future ones, I already got these tiny speakers and I'll try a different amplifier to see if it fixes the problem. Now for the movement. For this, I got a servo board and two servos, one for each arm. Servos are basically little motors that you can control precisely. You tell them the angle to move to and they move there. The servo board just makes it easier to connect all the servos to the Pi. Here's where I needed that I2C multiplexer I mentioned earlier. The servo board also uses SDA and SCL pins to communicate with the Pi, just like the screen does. Since the Pi only has one pin for each, the multiplexer splits them so both the screen and the servo board can connect at the same time. I also needed to get a separate battery case with 4 AA batteries. The Raspberry Pi doesn't have enough power to run them directly. Servos draw a lot of current when they move, and trying to power them from the Pi together with the screen, together with the speakers, could damage it or cause the whole system to crash. I connected the servos to the board and tested them to make sure they could move through their full range of motion. They move smoothly, which is exactly what we need for a natural looking arm movement. Now let's talk about the actual body. I designed it in 3 main parts. Legs with heavy batteries inside to keep him stable, a body block with arms that also hides the servos, and a head big enough to house everything else: the Pi, the screen, the amplifier, all the wiring. I want to get a 3D printer at some point for more polished builds, but for now it's cardboard held together with some pins. Simple, cheap, and honestly pretty effective for prototyping. I painted it purple because why not? He deserves some personality even before we program it. The design had to be practical. The legs needed to be wide enough to fit some random heavy batteries just for weight so he doesn't tip over. The body needed cutouts for the servo arms to move through, and the head needed to be big enough to fit all the electronics while still leaving room for the screen to be visible on the face. And there he is, my little guy. Alright, now for the hoodie. I thought it would be cool to give him a way to express himself by pulling hood strings and hiding in the hood. Turns out finding clothes for a disproportional custom-made cardboard robot isn't easy, if not impossible. I got this doll clothes that clearly doesn't fit him, so I decided to just make a hoodie myself. The last time I sewed something was in the middle school. I made a blouse that ripped on my classmate right during the presentation. So you can guess my crafting skills are like 1 out of 10. But I got some clothes, started with a prototype made out of Whole Foods delivery bags and pins to figure out the shape and sizing, and finally made it to a final result. I added a drawstring and glued some tiny pom-poms to the ends to make it cozy. And honestly, I'm pretty proud of how it turned out. He looks adorable. The hood fits well enough that his arms can grab the strings and pull it down, which is the whole point. Now we just need to teach him when to actually hide. So here he is, a complete body with all components installed and working. We got the LED screen for expressions, speakers and mic for communication, servos for arm movement, and of course a hoodie for when things get overwhelming. Everything is wired up, tested, and ready to go. But right now he's just hardware. He can't think, can't react, can't decide when to hide or pick out. That's all coming in part 2 when we actually program his personality. Before I go, I need your help with 2 things. First, I still haven't named him. If you have ideas, please drop them in the comment. Ideally, they should match his shy and introverted personality. And second, if you have any tips from me based on what you saw today or anything for part 2, please drop them in the comment, especially if you're a professional. I genuinely want to learn from you. Thank you for watching, and I'll see you in part 2 where we bring him to life. Subscribe for more robots.